Mass,
So let us come.
mass and velocity.
Yeah. Let us come to here. In today's class, we will continue. So in last class, I have taught you what is the applications of understanding. What is the applications of Newton's law of motion. So in that, as we know that we have seen last class, understanding. So what are the applications? Applications of third law of motion. Newton's third law of motion. Understand? So as we know, Newton's third law of motion, if you'll observe. So what is the first application? It will give you how do we walk? Is it yes or no?
Yes, sir.
How do we walk? How do we? Why it is difficult to walk on ice? And why? How we are swimming? This is all under this. So what is the second one which you have studied? What is the second one, Ra?
The recoil.
Why the
Recoil of gun.
What is the recoil? Please, anybody? Anything?
A sudden jerk of the gun.
Sudden jerk of the gun. Is it yes? Sudden jerk of the gun means in the sense of what? The backward motion of the gun. Is it yes or no? When the bullet is fired from the gun, then the gun also will travel in the backward motion. That is what we should call as what? Recoil or recoil velocity of gun. Is it yes or no?
Yes, sir.
Nobody will speak. Recoil velocity of gun. Laksha, what are you doing? Next, what is the third one, Ra? What is the third application which we have studied?
Flying jet aeroplane.
Flying jet aeroplanes and
Rocket.
flying jet aeroplanes and what?
Rocket and balloon.
Jet aeroplanes and rockets. Next, fourth one.
Boat.
Uh,
Boat and getting out from a boat.
moving boat and as well as what?
Getting out from the boat.
Getting out from the boat. That is what? Correct or not? So the flying of jet aeroplanes and rockets. And the next one is the case of a boat and the ship. The case of a boat and the ship. And the next one is like same way. I can see even more examples of that. The case of hose pipe. Do you know hose pipe? How many of you know hose pipe? Hose pipe. When we are pressing the press, water will fall down. Water will come while you are planting. Skating is also. So while watering the plants, will press at the edge so that water will fall very long distance. Have you noticed it?
Yes, sir.
So what is the reason behind it? What is the reason behind it?
Sir, when we decrease the area, the pressure will increase, sir.
Yeah. Next, is it only the thing? Is it only the thing? So here Newton's law also there. What is that? Can you able to say please? What is Newton's law is there? Please let me know.
Action and reaction.
So the fifth example is, all of you should write. The next one is hose pipe. I will explain. Write it. Hose pipe. In the case of hose pipe. In the case of hose pipe.
The screen is not shared, sir.
Okay. Right now. The case of hose pipe. The case of hose pipe. So let us discuss what is this. Shall we start, Manya? So now, as we know that, understanding while watering the plants and we will while transporting water, we will use this pipe. So, or else fireman. Do you know fire accidents? Fireman, fire engine will come. Fire people they will take some kind of a pipe. Or else in our school also fire accident, fire safety equipment. We have some kind of a pipe. Is it yes or no?
Yes, sir.
Yes. So you may observe very carefully the case of hose pipe. So what is happening means you may observe the fireman while he is keeping the water, while he is trying to keep the water, that water will be coming very forcefully and very large distance. Is it yes or no?
Yes, sir.
You may observe he will hold the pipe very tightly in his hands. Why it is handling? Why it is happening? If it is not holding, if he will hold with the one hand or normally, what will happen? Can anybody say? Here also Newton's law of motion is there. So why he need to hold very tightly that hose pipe? Nobody. So as we know that, understanding, the firemen are directing a powerful stream of water, powerful, very huge amount of water coming with a forcefully on a fire from a hose pipe. So they have they have to hold the hose pipe strongly, because if they are not holding tightly, it will tendency to go backward direction. Because why it is happening means, as we know here, the backward movement of the hose pipe is because of the forward direction of greater speed of water. So you may observe here, all of you, I will draw the hose pipe also, how it looks like. So now, as we know that hose pipe, you may see that basically the pipe will be like this, and the edge corner, they're having a metal cap like this. Have you noticed it? Metal cap.
Yes, sir.
Do you understanding, all of you? Yes or no?
Yes, sir.
So huge amount of water is coming very forcefully through that. Huge amount of water is coming very forcefully through that. So what is happening? The pipe is exerting force. The pipe is exerting force on this water, so that the water will fall on very large distance. Is it yes or no? Very large
Yes,
distance.
sir.
Now, when the force is acting in this here, the pipe is exerting the force on this water in the forward direction. So that what will happen, Ra? The water will exert the force on pipe and
Backward direction.
backward direction. Do you understand it? So backward direction. So that is only we should call it as what? Reaction. What we should call?
Reaction.
Reaction.
And pipe will exert the force on water, so that water will move forward very forcefully. That is what we should call it as what?
Action.
Action.
So that is the reason. If the person, those who are holding this pipe, is not holding tightly, then what will happen? Because of the force exerted by water on this hose pipe, so that the pipe will leave from our hands, it will escape. Understanding? It will escape away from us. It will go and will fall away from us. Do you understand, Ra?
Yes, sir.
The reason while we are holding the hose pipe, so we have to, the backward movement of the hose pipe is because the forward direction of water at a greater speed. So to avoid that, we have to hold the what? Very tightly. Understanding, all of you? Yes or no? So that is what you should remember. Understand, Manya? Okay. So that is what you should remember and write it. In the case of hose pipe, you can draw this diagram simply and you can write. So here, what is the action, Ra? What is the action? Can anybody say? What is the action? The force exerted by the pipe on this water is called as action, and the force exerted by the water on this pipe is only called as reaction.
Reaction.
To avoid that backward movement of this understanding, to avoid backward movement of this hose pipe, understanding hose pipe, so the person need to hold it very, very tightly. That is what you should write it. All of you. Do you understand, Ra?
Yes, sir.
Now write it. Firemen have to hold the hose pipe strongly. Fireman have to hold the hose pipe strongly. Fireman has to hold the hose pipe tightly. Why not tightly? Tightly because why? Because of its tendency to go backward. Because of its tendency to go back. Do you understanding all of you? So this is what the first application. So diagram you have to draw. This is the hose pipe. Understanding? This is called as hose pipe. So when the hose pipe is exerting pressure on water to exert the water in a forward direction, which we used to call as action. So water will exert the force on the hose pipe in the backward direction. That is what we should call as reaction. Do you understanding all of you? This is the diagram you should. Okay. Yes, that is the case number 5. So now let us come to the last case in this examples of Newton's law of motion or applications of Newton's law of motion. How many of you know bull cart or horse cart? Bull cart. Do you know bull cart?
Yes, sir.
Sir.
The case of horse pulling a cart or bull pulling a cart. So let us observe here. So there also it will happen something. So the right all of you. The case of horse pulling a cart. The case of last one, the case of horse pulling a cart. So what will happen right here? Newton's law, can you able to say where it will happening? The case of horse pulling a cart. Anybody please? Please let me know where you people will observe Newton's law. Please tell me. So as we know that, have you noticed it while the bull or horse or something it is moving? Understand? So while it is pulling the load, is it will bend forward or it will stand like this and it will walk? Is it will bend forward?
Bend.
Please tell me. How
It will bend.
it will bend forward. In this picture, all of you observe. So here, what is happening? All of you see. Speak here. What is happening here? So here, horse is pulling the
Horse is pulling a cart.
horse is pulling the cart, and you may observe here, horse is bending his head back forward direction. Is it yes or no? Bend. He is
Yes,
bending
sir.
in the forward direction. So as we know that when the horse is trying to pull the cart, understand? As we know that his legs.
Sir, when horse is pulling the cart, it is action.
Yeah, you can see here. What is the? So as we know that here, if it is trying to push the ground backward direction, what will happen? Ground will push it in the
Front direction.
push it in the forward direction. So with his legs, with the horse with its legs, it will try to push the ground in backward direction. So that backward direction is only we used to call as what? Action. What we should call? Action. So
Action.
understand, because of that, ground will exert the force on forward direction. So this forward direction is only called as what?
Reaction.
Reaction. But you may see, if this both will become equal, both backward and forward reaction both will become equal, then horse cannot pull this cart. Is it yes or no? Horse cannot pull this cart. Is it yes or no? Please let me
Yes,
know.
sir.
Now,
Yes, sir.
you can see it will exert the more force on this. Understand? So when this mass of this cart and this the force exerted by this horse both will become equal, then there is no movement in the cart. So that is why you can see all the heart or any kind of understanding, cows or bulls or horses, everything, they will bend their head forward, so that to increase the more amount of force means they will apply the more amount of backward force. So that is why they can move forward. Is it yes or no? Yes?
Yes, sir.
Remember. So let us apply this third law of action and reaction to the situation of horse pulling a cart. According to the third law, horse exerts some force on the cart and the cart also exerts an equal and opposite force on the horse. That is what? Because both are connected. Same like the ground. Is it yes or no?
Yes, sir.
But still, you can see, if horse is exerting some X amount of force on cart, the cart is also exerting some X amount of force on horse, both should not move. Is it yes or no? Is it yes or no? So there is no movement because both will become equal, opposite and both are equal and opposite.
Yes, sir.
Both will become what? Zero. Suppose you see. So horse is exerting some amount of force in the forward direction, 10 newtons, and cart is exerting say some equal amount of force in 10 newtons in opposite direction. Both will get cancelled. So finally what is happening? Zero. Is it yes or no?
Zero.
Zero means in the sense of no movement in the cart. No movement in the cart means cart cannot move forward direction. Is it yes or no? There is no displacement in the cart.
Yes,
But
sir.
still the cart is moving. Why? What is happening? What is the reason behind? Anybody?
So the horse exert more force.
Understand? It should be noted that only the force on the cart which determines whether the cart will move or not is the force exerted by the cart on the horse affects horse alone. But if the horse is able to apply enough force to overcome these frictional forces present, understanding, then the cart will start moving forward. That is why you can see, to make the cart move, the horse bends forward direction and will try to push us, understand, the ground with his feet very forcefully. Do you understanding, Ra?
Yes, sir.
When the horse is trying to push the ground, understanding, pushes the ground with his feet, what is happening? When the forward reaction to the backward push of the horse is greater than the opposing frictional forces of the wheels, so that the car will start moving. Do you understanding, all of you? So in this picture, you may
Yes, sir.
all of you observe carefully here. So usually when the force, if the some amount of force is exerting on the cart, then the cart also exerts same amount of force, so that usually both will get cancelled. So no displacement or no motion in the cart. No motion in the cart. But still the cart is start moving. Why, sir? Means because horse will apply more amount of force on the ground, frictional force. To overcome this frictional force, it will try to push the ground very fastly, understanding, with a more amount of force by bending forward, understanding, so that the frictional force will be overcome. So we can see that the cart will start moving forward. Is it yes or no?
Yes, sir.
Now, suppose you see, here load is very less, so that the horse is moving forward. Suppose if I increase the load, this much amount of load I will keep. Even though horse is trying to pull the cart very forcefully, is it possible to move?
No, sir.
No, because of increasing mass. Here, the frictional force is what is happening. Frictional force is increases much. Is it yes or no? So that
Yes,
even though
sir.
horse is trying to apply the push the ground backward direction for more forcefully also, it cannot pull it because of heavy mass. Do you understanding, all of you?
Yes, sir.
That is
Yes,
so
sir.
here also you can see, understanding, here also Newton's law is applicable. So when the horse is trying to push the cart, push the ground in a backward direction, that is what we should call as action. So because of this action, ground will exert a forward force on this horse. So that is what we should call as what? Reaction. So that is the
Reaction.
reason why the horse will start moving forward. Do you understanding, all of you? Manya and Samya, everybody.
Understood, sir.
Josh?
Yes, sir.
Yes. So that is what you should remember.
sir.
So this is all about, all of you should remember. So this is all about the Newton's law of motion and its applications. Understand? So that is what you should remember. So in some cases, observe very carefully, when the two bodies exert force on each other, even when they are not in contact, understand, with each other. So for example, you can take a very, very small cases, understand, like interaction can also take place even when two bodies are not in contact. So in all such cases, the forces action and reaction are equal in opposite. For example, you can take magnet you can see, magnet and can interact with some piece of iron. Is it yes or no?
Yes, sir.
So in that case, you see, magnet is exerting some force in a piece of iron. Then piece of iron also will exert what? Equal and opposite force on the magnet. Correct or not?
Yes, sir.
Yes. But why the interaction will take place? A piece of magnet will come and will stick to the magnet, piece of iron, because of magnet is having an attractive nature. Is it yes or no? So when the magnet is exerting some amount of force on the
Yes, sir.
iron, a piece of iron also will exert the same amount of force. They are exerting the same amount of force, understanding, equal and opposite, but still the iron piece will be attracted by the magnet because of magnet is having attractive nature. Do you understanding, Ra?
Attractive nature.
Yes, sir.
So that is what you should remember. So from this we can say, from this all the examples we can say, Newton's law of motion will occurs only always how many bodies?
Two bodies.
Two bodies. Understand? So is it possible to exit in one single body, action and reaction?
No, sir.
action and reaction, it is not at all possible to exert in single body. Always we need two bodies. Do you understand, Igra?
Yes, sir.
Yes. So now, this is all about the applications of Newton's law of motion. So from this we can say, always the forces, understand the forces always occurs in pairs, and Newton's law of motion concern these pairs of forces. Is it yes or no? The pair of forces. That is what you should note it down. Finally, how to conclude that point? Write it. All of you. All of you. The case of horse pulling a cart also. Okay. Now you write it. The forces always occurs in pairs. The forces always occurs in pairs. Note. The forces. Tarun. The forces always occurs in. Is it possible to produce action and reaction in single body?
No, sir.
No, sir.
The forces always occurs in pair. Occurs in pair. Tamil Selvan, do you understanding? Avanish, Laksha, Manya, and Samya, pairs. And Newton's law of motion concerns this pair of forces. And Newton's law of motion and Newton's law of motion. Laws of motion concerns these pairs of forces. Is it okay, Ra? So this is what about these applications of Newton's law of motion. Is there any doubt? Anybody you can ask me. In exam you can write. They will ask usually one or two. So you people can write anything. Is it okay, all of you?
Sir.
Yes, sir.
Let us start.
Yes,
The next
sir.
concept is very, very important. All must learn this derivation. The next concept we are going to study is conservation of momentum. Drop your pens and you listen. Later, once you understanding, you can write it. Conservation. Conservation of momentum. What is this, Ra? Conservation of momentum. Do you understanding, all of you? Shall I say?
Yes, sir.
Yes. So let's proceed now. Very, very, very important. Understand? So this definition will come so many times. So you have to remember that. So 1 minute. Oh, okay. Pradosh is asking you to scroll me up. Oh, okay, Pradosh. Just finish it. All of you finish it fastly. Arun, please mute yourself. Some sound is coming. Okay. So now, shall I start, Ra? Conservation of momentum. All of you keep heading. Conservation of momentum. Is it okay, Ra? Please let me know.
Yes, sir.
Yes, sir.
So now, so let us consider what is this conservation. Understand? All of you please listen carefully. And if you have any doubt at anywhere, please let me know. Because this is a derivation which we used to study most important, because of with this only we have a lot of numericals we are going to start. So that is what let us consider. So conservation of moment. Now, as we know that in the second law, before second law, understand we are studying F equals to ma. We have studied that moving bodies possess momentum. Understand, which is the equal to the product of mass and velocity. Is it yes or no? If we take any kind of moving body, what is momentum? Please let me know. What is momentum, Ra? What is momentum?
The definition of
Momentum equals to what? Momentum of any body is equals to what? Is equals to mass into velocity. Is it
velocity.
So this is what we have studied. So momentum P is equals to, it is the product of mass into velocity, which we have already studied the before Newton's second law of motion. Is it yes or no? Laksha,
sir.
Manya, everybody. Darun, Tamil Selvan. Now, we have a use of this. Let us discuss. Now, as we know that if the momentum created by a single body, which we used to call as, understand, mass into velocity. Mass into velocity. Now, let us consider two bodies. So let me consider body A and body B. Both are moving in the same direction. You have to remember it. So For that purpose also I will say. So now let us consider, we'll take to understand the example of meaning of conservation of momentum. I am saying here, not momentum. I am saying a word called as what? Conservation of momentum. What is this?
Conservation
Conservation of
What is the
momentum.
meaning of conservation in a geography or somewhere it will come? Conservation means what? Saving.
Sir, prevent.
Prevent, understanding, preserving.
Protecting.
So same way here, conservation of momentum mean. So to understand this conservation, so let us take one example, then you can understand more better. So we have to derive the derivation also. Suppose, let me take one truck, fast moving truck hits a stationary car. Understand? So what will happen, Ram? Suppose the car is kept in a stationary. Now fast moving truck will come and will hit the truck. Will hit that moving car. Stationary car. What will happen? What will happen? Please tell me. This is the most important one. For understanding conservation, you have to tell me. Suppose see, the truck is moving very fastly. Now here, let us imagine the car which is in a rest or stationary. Now this fast moving truck will come and will hit this. What will happen? Please tell me. What will happen?
The car will smash.
The car will start moving forward little bit. Is it yes or no? Because of fast moving truck. Correct or not?
Yes, sir.
Yes. So now, please tell me, all of you, try to understand very carefully. Then only you can solve it. Understand this under conservation of moment. For example I am saying. So example, let us consider the fast moving truck. This is the fast moving truck which is coming very fastly, very fastly. So what is the momentum of this? Can you able to say? What is the momentum of this truck? Momentum, let me imagine, this is momentum is equals to, let me consider mass m1 into velocity v1. Is it yes or no?
Yes, sir.
All of you, this is what the fast moving truck. Fast moving truck. Now, here, the car is at rest. The car is at rest. Initially, the car is at rest. Example I'm saying, later I will explain very clearly. Car is at rest. What is the momentum here? Let me consider P2 equals to
0.
Mass is M2 and velocity is what? V2 equals to what? 0.
0.
So P2 is equals to 0. Is it yes or no?
Yes, sir.
No. So what is the total momentum? What is the total momentum in this case? Please let me tell you. What is the total momentum? Total momentum P is equals to P1 plus P2, which is equals to what? P is equals to P1 plus 0, which is equals to what?
P1.
P is equals to P1. Means whatever the momentum gained by the truck, same momentum is present before hitting the car. Is it yes or no?
Yes, sir.
Now, truck is moving very fast. Now, if it will come and will hit some kind of object, definitely its speed will decreases or increases.
Decreases.
Or increases. Please let me know.
Decreases.
So, as we know that this one is coming and hitting the car, which is a stationary. So, if it will hit the stationary car, then the car will start moving or not forward.
Yes, sir.
The car will start moving forward or not. Little bit, man.
Yes, sir.
Yes. So now, as we know that when the car, understand, when the truck will come and will hit, then definitely the speed will decreases. So speed will decreases means momentum will decreases or not?
Yes, sir.
Momentum will somewhat decreases. Correct or not? So now,
Yes, sir.
momentum, understanding momentum of this car, P1 is equals to, mass is not changing, mass will never change. So definitely speed will decreases so that it is having some speed. Is it no? Let us imagine.
Yes, sir.
Now, because of hitting the, so this car will start gaining, car will start moving little bit forward direction. Means in the sense of, it will gain, its velocity increases or not? Speed will increase or
Yes,
not?
sir.
From rest
Yes,
speed to
sir.
moving, correct or not?
Yes, sir.
Start moving so that the body is having some motion or not, some motion. So means in the sense of, it will gain some momentum or not?
Yes, sir.
Yes. So now, here some momentum is decreasing, here some momentum is gaining. So, but both if you add, totally is equals to what? Initial momentum of the truck. Is it yes or no?
Yes, sir.
Definitely. Suppose you see here, I am having 100 rupees, and in this case, I am giving to Yelamukila Tarun, I am giving to 30 rupees, and I am having 70 rupees now. So now totally, what is the total momentum here? Tell me, what is the total rupees? Total rupees of
100.
which is equals to 100. And initially, what is the total amount? Initially, I am alone. What is that? 100. After sharing also, my total amount is 100. So means in the sense of what? Before and after, it is equal 100 only. Correct or not?
Yes, sir.
That is only called as conservation of momentum. Means the momentum before collision and the momentum after collision is equal. That is what we should call it as. Understand? What we should call? Conservation of momentum.
Conservation of
You
momentum.
understand, Ikra? So means two
Yes,
vehicles
sir.
are present. Whatever the momentum of that vehicles before collision, understanding. After collision also the momentum is equal. But because of collision, some vehicle speed may decreases and some vehicle speed may increases. Correct or not?
Yes, sir.
But the total momentum if you do, overall momentum if you calculate, the total momentum is equals to what? Total momentum before collision and total momentum
After collision.
after collision. Understand, Darun, Mavanish? That is what we can say, conservation of momentum. So, you may understand this very well. So, because of hitting the truck is hitting the truck speed is decreasing and the car speed is increasing. But if we calculate the momentum of the truck and the car after hitting, that momentum is equals to, total momentum is equals to the momentum of the truck alone when before hitting the car. Do you understand, Inga?
Sir.
That is what we can say, law of conservation of momentum. So please also write, according to the law of conservation of momentum, according to the law of conservation of momentum. Conservation of momentum. I will explain the derivation very nicely. Don't worry. Conservation of momentum. When two bodies act upon one another. When two bodies act upon one another. When two bodies act upon one another. Act upon one another means what, Ra? Collision. Do you understand, Ra? Act upon one another means what? Collision it is. Do you understanding, all of you? Collision means hitting.
Yes, sir.
Hitting. Act upon one another. Act upon one another, comma. Their total momentum remains constant. Their total momentum remains constant. Comma. Their total momentum remains constant unless external force is applied. Is it yes or no?
Yes, sir.
Yes, that is what remains constant provided no external forces are acting. Provided, so this constant only what we should call? Constant only known as conservation. What we should call?
Conservation.
Constant is only known as conservation provided no external forces are acting, comma, provided no external forces are acting. Do you understanding, all of you?
Yes, sir.
This is what we should call as Tarun, Monish, Pradosh, Laksha, Samaya, everybody. So this is what we should call as law of conservation of momentum. Means momentum before collision, which is equals to what? Momentum after
collision.
So, momentum before collision, which is equals to the momentum after collision. That is what we can say, law of conservation of momentum. Now we have to prove that momentum before collision, which is equals to momentum after collision. Is it yes or no? Is it equal or not? We have to prove it. So for that purpose, I am taking understanding. So let us consider two bodies. Suppose one is truck and a car. One is truck and one is car. Shall I start, Ra?
Yes, sir.
So now, observe very carefully. I will draw the diagram. Same way you have to consider. So to prove that, I will take two bodies. One is, suppose, let's consider two bodies. Consider two bodies. One is what? One is
Truck and car.
and the second one is car. Both you take. Now, sorry. So now you can hear it is a biology actually last class. Okay, let it be. Now you can consider here. So let me consider the truck. All of you have to draw along with me. This is or else you can consider like in your textbook you can draw the balls also, it is correct only. But it is, if you take the truck, it is more even beautiful and we can study nicely. Correct or not? That is what I am saying. So this is what the truck I am having. So now what is the momentum of this truck? Can you able to say all of you? Let me consider this is the mass m1 and the initial velocity v1. This is before collision and this is the car. Car is moving in the same direction. Car is moving in the same direction. Both are moving in the same direction. Please tell me what is the momentum? What is before collision? This is considered before collision. Before collision. So what is the mass here? Mass is m2 and the initial velocity is u2. Is it yes or no?
Yes, sir.
So what is the momentum of the truck? Please tell me before collision, what is the momentum of the truck? Let me consider P1. P1 is equals to what? M1 U1 and P2 is equals to what?
M2 V2.
M2 U2.
U2. Now, what is the total momentum before collision? Total momentum P is equals to P1 plus
P1 plus P2.
understanding, and P1 plus P2 is equals to what? M1 U1 plus M2 U2. This is what the momentum before collision. Will you accept it, all of you?
Yes, sir.
Yes, sir.
Now, they both are hit. Now, truck will come and will hit the car. This is during collision. So, during collision, no momentum because momentum is exchanging by that time. Is it yes or no? So, momentum
Yes,
is
sir.
exchanging. So, by that time, nothing will happen. So, momentum is exchanging now. So, collision will take place. So, some damage will take place to the car also. Correct or not?
Yes, sir.
That is what will happen. So, this is what? During collision. What we should call?
During collision.
During collision.
During collision.
Both are hit each other. So now, during collision, collision is over. Collision after what will happen? After collision will come. What will come?
After
collision.
collision.
So after collision, suppose you are driving in a front truck, your truck will come and will hit you. So again you will start moving in the same direction. Is it yes or no?
Yes, sir.
That is what you can remember. So this is what after collision. All of you should remember. This is what after collision. So after collision, some damage will take place at the front part, and for car, some the back part. Is it yes or no?
Yes, sir.
So that is what I am showing the damage also. But still they will move in the same direction after collision also. Now what is the mass? Here mass is what? M1.
M1.
And definitely some velocity will change. Is it yes or no? That is
Yes,
V.
sir.
And here also mass is M2. Velocity, what is the change in velocity?
V2.
V2. And everybody should speak. Now, what is the momentum? Tell me after collision. This is after collision. This is after collision. After collision. So the bodies will start traveling in the same direction. So what is the momentum of the truck? Please let me know. Momentum of the truck, which is equals to P1 is equals to
M1 into V1.
Next, P2 is equal